All right, Lily, we are back with lesson 17. Um, Everything looked great on 16. Um, Seemed pretty easy and like you picked it up pretty well. So let's just jump right into 17. Um, we're on page 93, somewhere in that range. Um, so the opening exercise has to deal with contextual situations for parabolas or quadratic functions. And that's what the performance task will be on. So hopefully you got the work that was sent home, the two practice graphing packets, and the pumpkin launcher uh, practice performance task. After this video or a couple videos, depending on how long we go, you should be able to jump right into those. So there'll be no formal homework or practice outside of the video other than the paper packets that you should have gotten at home, hopefully by the time you watch this. So let's jump right into it. High school baseball player throws a ball straight up into the air for his math class. The math class was able to determine the relationship between the height of the ball and the time since it was thrown, because it can be modeled by the function h of t equals negative 16t squared plus 96t plus 6, where t is time in seconds since the ball was thrown, and h is the height in feet. So we are going to go through all the information piece by piece and everything the equation tells us and everything that the problem tells us. So first thing we're looking at is the domain. So the domain of the function is all the x values. So what are all the x values that are relevant to this context? So in this situation, the x-axis would be time in seconds. So the domain would be the time thrown up in the air until it landed. So if we want to just kind of sketch out on an axis what's actually going on, we're throwing a ball into the air and it's coming down back to the ground. So the domain represents everything from here to here. Now, with the equation itself, obviously it would continue down here and down here, but that doesn't matter because that has no relevance to the context of the situation. So going on to the ranges are y values. So now I'm talking about the distance on the y-axis. And so it starts there and it goes up to what we call a maximum height. And that interval is the range. So the range is represented by the y values. And in this context, it's the height thrown to the maximum height. So it's going to go up into the air until it reaches its maximum height, and then it'll start to come back down to the ground. At what height does the ball get thrown? So this is where the standard form of the equation, which is what we're looking at here, if you remember, we'll go back to a standard form of y equals ax squared plus bx plus c. So that's our basic standard form for a quadratic. The c value is my y-intercept. So if I think about that in terms of context here, when t is 0, when I first have the ball, that is going to be my initial height. So with height, when time is 0, and I replace t with 0, I will get my initial height. And what you'll find out is that 0 squared is 0, times negative 16 is 0. 96 times 0 is 0. So whatever constant, whatever c value, that is the initial height. So this would be 6 feet. So hopefully you saw that you really didn't have to do any math. You could just look at that constant term, that c term that is not attached to a variable. And that is your initial height. That is the height the ball is above the ground. Which makes sense if you think about it. If you have a person throwing the ball, they're not going to be lying on the ground and launching it up. They're going to probably be standing up and releasing the ball at a certain height. So if you think about the process of throwing a ball, it would probably be around 6 feet, maybe a little under, depending on the height of the person. The math comes in when we get to part B and E. So after how many seconds does the ball hit the ground? So this is where I need to use my previous knowledge of a quadratic equation. So on the ground, the height is going to be 0. So I can set my equation equal to 0 because h of t is height, and that is 0. And I know that my equation in terms of t gives me that. So solving for t, I will get the 2 times, because I'm going to get 2 answers because it's a quadratic, at which the ball is on the ground. So let's go to a blank screen so we can just show the math out. And this is where you have autonomy as to which method you would like to use. So we could factor. We could complete the square. Or we could use the quadratic formula. Either one of these methods is perfectly fine. Some are obviously more efficient than others. But whatever you prefer, whatever you feel most comfortable, you are welcome to use. So I know the quadratic formula works every time. And I'm not 100% sure if this factors just by looking at the equation. So I'm going to use the quadratic formula. So t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I'm just going to work through that problem utilizing a calculator where necessary. So 96 squared is 9,216. Four times 16 is 64. 64 times 6 is 384. And because I have a negative and a negative in there, it's going to be positive 384 over negative 32. 9216 plus 384 is 9600. Square root of 9600 is 97.98. And now I can get my final two answers because this is going to break off into negative 96 plus 97.98 divided by negative 32 and negative 96 minus 97.98 divided by negative 32. So I will get the 2 times at when the height is equal to 0. So negative 0.06 and then 6.06. Now again, we need to think about this contextually. The negative 0.06 cannot happen. I cannot go back in time, and that's what the negative is indicating if time is our x-axis. Which means 6.06 seconds is how long it'll take for the ball to go up in the air and come back down and hit the ground. So the answer to D, using all that math, would be 6.06 seconds. So then we have to find the maximum height. And I need to find the vertex in order to do that. And there's a very specific way we're going to find the vertex from a standard form equation. And I'll start that off in the next video. So we're not going too long. Try to keep them under 15 minutes each. All right, so part 2 coming up.